denominator. And just for sake of argument, I'll throw this at your 4th grade style. The top component is the numerator. The bottom component is denominator. Okay, adding and subtracting like fractions means that they have the same denominator. Okay? Look at the astronomy story problem. Boy, are they scraping the bottom of the barrel. One night, 77/100ths, 77%, so to speak, of the moon's visible surface is illuminated, and the next night a little bit more comes into play, adding an additional 9/100ths. By the way, this is example 1. I know it's right there in the book, but adding an additional 9/100ths of illumination. What fraction is now illuminated on the second night? Night 1, this gets added. Eli, night 2 gives us 86. He's right. In order to come up with 86 over 100, you simply combine those two numerators, right? 77 and 9, which gives you 86/100ths of the moon's visible surface is now illuminated, right? By the way, a lot of your homework assignments said reduce, 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 reduce. And if you gave me this, what do you think I would write? Reduce. Grace, reduce it. Cut it in half. She's right. And 43 is a prime, is it not? Which means you can't go any further. Your final answer should be 43/50ths. Okay, let me ask you this. During a new moon, science meets math. What fraction of the moon's surface is illuminated? Wow, none of you are as nerdy as me. Rachel's rolling her eyes at me, so is John. Oh my word. So a full moon means what? 100% of the illuminated surface is illuminated, right? And then it goes and it's crescent and it's that little sliver. And then new moon is the phase when you don't see the moon at all. What fraction is that? Yeah. Yeah, 0 out of 100. Okay. Moving on. Here's my example 2. Guys, I know this is easy, but I promise you that if you're not paying attention, there are easy mistakes to be made, so let's not sign up for those. Got a couple of examples I want to share with you. Here's example 2. A, we're going to combine -4/9 and -7/9. Remember, when you're doing subtraction, you can think of it as I don't know if you guys remember that or not, but this is the same as this. Subtraction is the same as adding an opposite. The opposite of 7 is -7. At any rate, the denominator in your answer is going to be what? Denominator. 9, we know that. And this, my friends, is the result of -4 and -7. This down here is the result of combining a -4 with a -7. Both mean the exact same thing, which is what? Good. -11/9. Now I know some of you are going to say to me, do I convert these to mixed numbers? The back of the book does still show these as mixed numbers. Okay, so that would be what? -1 2/9, if I did my arithmetic correctly. Okay? Or maybe I might have, here's yet another example. -16 17ths minus negative 15 17ths. Remember how I showed you guys up here that subtraction is the same thing as adding the opposite of the second number? So if that's the case, then the subtraction down here is the same thing as adding the opposite of the second number. By the rule, you guys know this rule. So your end result is going to be whatever negative 16 minus a negative 15 is over 17. Or rewritten, this one's a little cleaner, negative 16 plus 15. What's the result? Negative what? Negative 1/17. The combination of negative 16 and positive 15. When you're combining two different signs, subtract the number and keep the sign of the bigger looking one. The one with the bigger absolute value, to be more specific. How about something super easy? Like this. Anybody know the answer to that? It's just 2/3, right? Don't make this hard. Okay? Just because these look ugly and have all these symbols and signs involved, you're still just doing this. Okay? It's not hard. The one detail I don't want you to forget is how subtraction is merely the same thing as adding the opposite. Mixed numbers. Now, they show you one way of doing it. I like to show you a slightly different way. I don't really care which way you do it. All right? Your way is, as long as you get the right answer, whichever way you choose is fine. Here's example 3. This is adding mixed numbers. Now, their school of thought is make them improper and then combine via addition or subtraction. The other school of thought is to combine as is and then correct your answer, and I'll show you what I mean by that. So I'm going to show you my way and then I'll show you their way. Here's the first one. 2 and 11/12 added to 6 and 7/12. Let's add our fractional portion. What's our fractional portion? 18/12. What is our numeric whole portion? 8. When I said correct as necessary, I mean if it creates an improper fraction, that then gets turned into a mixed number. What would this be as a mixed number? Go ahead, Jewel.
9.5.
Well, what would this portion be? You're right, but what would this portion be?
1.5.
She's right. 1 6/12, which is 1.5. She added the 8 to it and came up with 9.5. So when I say correct it, that means fix any improper stuff, combine it with the lingering whole number that was laying there waiting for you. The way they do it looks like this. And either way is fine. They make it improper. 2 times 12 is 24, 34, 35/12. And if you see me make an arithmetic error, please bother me. 6 times 12 is 72 plus 9, 79. Okay, we're still adding, still the exact same problem. What is the sum of 35 and 79? 114. So right now I have 114 over 12, which I bet you is 9.5. Is it? If you divide it in your calculator, it'll give you 9.5, but obviously we're looking for fractions, so it has to be 9.5. If you give me this and it asks for fractions, you're going to get it marked wrong. A lot of you got that on your homework yesterday too. You gave me fractions instead of decimals or vice versa. So I don't care if you want to do it this way or that way. Either way, you're going to have to do some work. Okay, it doesn't matter to me how you do it. Let's do a subtraction version. Let's do 8 and 9/15 minus 10 and 2/15. Making it improper. Combine as is incorrect. 8 and 9/15 minus 10 and 2/15. Now you guys, depending upon how you like to do this, either way is fine. Doesn't really matter. It is kind of tricky though, I'm not gonna lie. So you might be thinking 9/15 minus 2/15 is 7/15, and 8 and negative 10 is 2, right? You might be thinking that would work, but it doesn't quite work that way in subtraction when you have a larger number on the bottom. In subtraction, this method is a little bit sticky. I'm just going to warn you right now. Okay? For whatever reason, I make more mistakes with this method than I do with this method. So for subtraction, I generally do it this way, and I'm going to just show it to you real quick. What's 8 times 15, everybody? 120 plus 9? 129. So I've got 129 over 15 and 152. 152 over 15. So this is positive, this is negative. Combining a positive 129 and a negative 152, you end up with a negative 23, right? So negative 23 over 15, which is 1 and 8/15 negative. Is that right? Like I said, this method, for whatever reason, I always make mistakes that way. So I highly recommend doing it the improper way, at the very least for that one. It's just cleaner. All right, the last thing I'm going to share with you, and this is continuing on the next page, example 4. Last thing. And by the way, the book has several examples of this whole making improper technique, so you can see those examples on page 226 if you need more. Okay, example 4. What if it's a fraction that has a variable in it? Doesn't change anything. Here's the first one I want to do. 3k's over 28 added to 9k's over 28 is how many k's over 28? Yep. Now here's where it gets a little bit tricky. Do you guys remember how we reduced this kind of a thing? 12 and 28. What can that reduce by? 4. By 4. So this becomes a 3. That becomes a 7th? A 7? And the k stays right where it's at. You must reduce where possible. E. 4 over 7y minus 9 over 7y. That's like saying whatever 4 and negative 9 combined are over 7y. So what is the sum of 4 and -9? -5. And does the denominator change? No, it never does when you add unless you reduce something. And we don't have to reduce anything here because 5/7 doesn't reduce. Okay? All right, folks. 10 through 44 all, please.